Hello everyone, my name is Arvid, and in this video I want to show you the power of the utility nodes inside of Maya. So let's jump right in and open the new Maya 2017. I have already prepared a lighting scene with this figure on the left and a really simple lighting setup with one area light and one HDR light. I am using Maya 2017 with the built-in Arnold renderer. I will be using third-party nodes from AlShaders. You can find them online on this website here. And at the bottom of the homepage, you can find install instructions for your Maya. Also, there's lots of references to all the nodes and all the shaders he has. Also, some tutorials online as well. So let's head back to Maya and open up the render view and the node editor. So let's start the IPR session. I just want to quickly explain all the buttons inside of the Arnold render view. This button on the right just says I will receive signals to update the viewport. So when this is clicked and disabled, whenever you change a value inside Maya, it won't trigger an update. So to do that, enable this and you will always get live feedback inside of the render viewer. This one stops the current render, but it is still active, so it's listening to events. So whenever I change a value again and press play, it will start the render again. So it won't retranslate the scene. Also, in the toolbar icons, I enabled the debug shading icon. So this is actually a drop-down menu to have shading presets for your scene, to quickly debug your scene. So let's start with shading. And let's create an AL surface shader. And clicking in here, you can select objects and right click and assign. So now we have the AL surface shader connected. The first thing I want to do is create an AL remap color node, which is essentially a color correct node, which has an input, a mask, and an out color. I tend to use this as my default diffuse color. So I mostly plug the out color into my diffuse color of my shader. So I can change the color. So let's choose something like this as my base color. Let's call this just base color, so it's more apparent what is happening. So the first node I want to talk about is called AL curvature, which is a curvature shader to give you the surface normals as a mask. So let's create this AL curvature. And let's connect output R color into my mask slot and change from shading to isolate selected. So whatever I select in here will render. By changing the radius, you say how sensitive the curvature threshold is. So the smaller the value, the more accurate the result will be. Also in the curvature node, you've got remaps, so you can directly adjust the output. So the out color R is driving my base color. So if I select the base color now and change a value, let's say I reduce the exposure, you can actually see that I am changing the diffuse color on only the edges. The shading result looks like this. So you get a better representation on the edges. So if you want to have a strong effect on this, let's reduce the exposure to -1 to get an even stronger effect. Next up, I want to change the surface roughness on the edges. So I will use the same mask, but this time I will drive a roughness map. So let's create an AL remap float and call this spec R remap and plug in the R value into the mask and the out value to my specular 1 roughness slot. The remap node has an input value, so currently everything has a roughness of 0, which is super glossy. But I want the default roughness to be 0.2. So we get an overall slight roughness. Let's say 0.3, the default value is actually quite good. So you get a roughness here, and now I want to increase the roughness on the edges. So let's first see how the mask looks like. So this is my curvature mask, and the remap is still just one color. So let's change input min and input max. So now I'm actually clamping the values, and the edges get a float output value. I'm checking here, getting a value of now 0.37. So let's increase this. So the whiter it gets, the more rougher the surface. So now it's 0.5, and let's see what the shaded result looks like. So now you can actually see that there is a rougher texture on the edges. These bigger surfaces are so smooth, I want to break them up a bit more using a noise map. So I like the AL flow noise, which is a very powerful map. So for now, let's just connect this to an ID slot, which is essentially just giving me a free slot so I can see what the node looks like. So changing back to isolate selected and changing the mode from UV to object, I can see what the map looks like. Currently, the frequency is way too low, so let's do 50, and you get already a nice breakup. So by adjusting the gain, you get a more detailed map. So if I switch to perspective mode and enable 3D manipulation, I can actually pan inside the render view. And this is now what the map looks on close-up. So let's give it a bit more gain so we get even more detail. The advection is kind of a distortion. Let's say I want to multiply this value with the curvature with this value, and I want to drive this for my spec intensity map. So let's create AL combine float. It takes two inputs, and actually this input 3 is more like a mask or a mix node, like a nuke. So let's for now connect the curvature into input 1 and the out color R of the flow noise into input 2, and connect the out value into the specular 1 strength. Sometimes you need to update your render view session, which retranslates all the nodes. So now coming from this guy and this guy, they get multiplied together to give me this breakup. The combine operation is on multiply. You can play around, use different values. The lerp, for instance, is the mix. So when this value is on 1, it will take input 2 completely. When it's on 0.5, it's a mix of both. And 0 will be the input 1. But I like the multiply because I get some really nice breakup on the white parts because it's multiplying with the black flow noise patterns. You can also remap them. So let's just try to contrast the map a bit more, so the breakup is even stronger. And let's have a look what the shaded version looks like now. So now you get actually some really nice breakup on the specularity. Alright, let's try something new. Let's create a car paint shader. I know it's not a car, but it will still work. I want to create a nice flake shader. First, I want to create a base reflection color. So let's head over to Specular 2 tab, increase the strength to 1, change the Fresnel mode to metallic, and the distribution to GGX. So let's create a blue car. Let's try something. I don't know, something like this. Maybe make it a bit rougher, maybe 0.55. And and how the shader is set up on the base, which is the metal part, we will introduce some flakes. And on top of that layer, there is a clear coat layer which gives the car its shininess. So let's start working with the base and create an AL flake. Right click on the base shader and say show all attributes, and then search for either in here for specular to normal, or search it manually, and the out value from the flake 1 connects to the specular to normal. So currently you can see that there is an update. Let's change the size to 0.5, and now you can already see that something is happening with the surface. Let's do update full scene. and change from tangent to world space. Also, the amount drives how many flakes are created. By reducing the size, you can see what is actually happening. And I'm getting a nice looking flake. Currently, we still need to adjust it because the divergence is way too big. But first, reduce the size to 0.015. So now we're getting a detailed flake pattern. So the divergence is actually the bending of each flake on the surface. So when this is to 0, you will get as if there is actually no flakes at all, a flat surface. So heading back over to my perspective camera and slowly introducing divergence, you can see what is happening on the surface. We are introducing the flakes, and on the edges you can really see what's happening. Let me reduce the size a bit more to 0.05. So now we get a really detailed and micro noise, which looks like a nice flake shader. Jumping back to camera, you can now nicely see what is happening. For this tutorial, I will just increase the size so we can actually see what is going on the surface. Sometimes when you have moving objects and you don't have a pref pass, you can use the AL input vector, or you can choose a P, which is a position pass, and put this to a vector, and this would connect to the P of the AL flake. So now whenever your object is moving, the flakes will move correctly with it. Let's add an edge tint color to this. Let's make it something purple or red to give us a nice edge tint. You can slightly see that it is now a shimmer of purple on the edges. Let's introduce the specular one lobe. And now you can either leave it on dielectric, but I tend to switch this as well to metallic by changing the reflectivity and edge tint color to be black, which is essentially the same as dielectric and an IOR of 1.4. As you can see, there is no visual difference, but you get way more control using the reflectivity colors. So this is now a super clean car paint shader. What I want to do now is introduce some edge dirt on top of this. So to achieve this, I want to use an occlusion shader inside my shading network. So let's create an AI occlusion, AI ambient occlusion, which ships default with Arnold. Or what you can do is use the AI utility node, which is also a shader, which also has occlusion. This will be a bit faster to calculate, but this gives you more control over the occlusion. So let's first have a look how this looks. Let's change the mode to be ambient occlusion, and in here you can drive the distance. So let's first assign this and change the distance. So this is now the occlusion distance. So what you can already see is that we get a nice edge creases, which would already look nice for the occlusion part. But you don't have any options to clamp or add some spread or fall off. You can do this with the AI ambient occlusion though. So let's connect this and change the far clipping, which is essentially the distance as well. And then you can play around with the fall off or the spread, which clamps the outputs. So now let's use this map to create a dust layer on top of the existing shader. I won't use a layered shader approach. I will use this occlusion to drive all the values inside the shader. So the benefit of doing this is efficiency. It doesn't have to calculate another shader and its samples. So this will be faster, maybe more difficult to set up, but you will win in the end. So let's create the shading network for this. So I have the pure occlusion shader. So first what I want to do is create a dust shader. And to accomplish this, we need some diffuse color, but we don't want to break the metal on this. So what I want to do is use the occlusion to drive a mask, which controls where I want to introduce diffuse color. So let's use an AL remap float, which controls my diffuse strength. The out color R connects to the input. Let's update the scene and switch to isolate selected. So this is now whatever will be white will have a diffuse strength. So I want to invert this, so only the dark parts will get diffuse color. So let's first invert by inverting those values. This needs to be 0. So everything which is white will get a diffuse contribution. But first let's clamp some values. Alright, and this now drives the diffuse strength, and the diffuse color is currently black, but let's create some dust color. So now you can already see what is happening. I am introducing diffuse on top of my car paint. Currently, the specular is unaffected. What I want to do is change the roughness on the dust and the specular intensity on the dust. So I'm using the same maps. This will be driving my roughness, and the inverse of this will drive the specular intensity. Duplicate this, and another time. So this will be my spec weight, and this will be my spec roughness. First, I need to find out what the current value is for the specular weight. Currently, it's fully 1. So let's see what it looks like. This guy would connect to specular 1 strength, which is the top coating layer. So whatever is white will be fully reflective, and whatever is black won't have any specular reflectance. So I want to invert this. I want the dust to almost have no reflectance, but the rest should have. Because I duplicated it from the diffuse strength, I need to re-invert this. So now it's actually the original value, and only the black parts or the darker parts won't get specular intensity. So let's see what this looks like. So this spec R here will drive the roughness on the dust surface. So let's connect the out value to spec roughness. So the whiter the value, the rougher the surface. The black values mean 0 roughness, so it is a super clean surface. So let's change the output value, the output min to something more grayish. No, which one is it? There we go. It's always hard. I always tweak around to see what is actually happening. Essentially what I want to do, I want to clamp the min to be something. So now I'm introducing some roughness value. So this is now 0.02, which is quite low. Let's first increase this some more. And the whites is definitely too strong, so let's reduce them as well. So now we have something in the range. I'm checking here at those values. So we've got something about 0.149, and the dust is at 0.4. It can be a bit stronger. So let's adjust the output min a bit more. Alright, this looks actually quite good. Let's see how the shader looks like. So now you can see that you get really some nice glints on the edges, which are fully reflective. And on the dust surfaces, you get some rough reflection. Alright, let's work on a glass shader. So now I will disconnect all the inputs, and I will revert the shader to the default AL surface. I've got a preset for the default values. So this is my flake shader. Heading over to the AL base shader, disable diffuse value, and for now let's disable the specularity. Let's bring back some transmission to make the object refractive. Currently it is black because my render settings are really adjusted for speed. So first let's go to the render globals and enable refraction. Also let's give it one sample. What I also need to do is increase the refraction depth. Let's do something like 5. So now you can see we get some refraction happening. Let's bring back the specular 1 lobe. And head over back to transmission to the advanced tab. In here you have scattering and absorption coefficients. So let's enable specify attenuation coefficients and changing the scattering and absorption to be black. So this is now the default behavior. The absorption means what light is being absorbed, which color. When I increase this, the more of the white light gets absorbed, and essentially everything gets absorbed and it's almost dark. If you want to create a blue glass, you would think you would set the color for absorption to blue, but it's actually the opposite way. So if you would set this to be blue, it would absorb the blue light and it will look yellow. So what you want to do is you want to put this to a yellow color so that color gets absorbed and the result will be a blue looking glass. The more saturation you introduce, the richer the color gets, because the more saturated yellow gets absorbed, the more or the richer your resulting color. In the AlShaders, wherever you can see a question mark on the attribute, there are some presets hidden, so right click on those values to access the presets. Let's say we want to create some milk. With my current lighting setup, this looks way too bright, so you can change those values to adjust it for your needs. Let's try something else like apple juice or Coca-Cola. These values are scene dependent, so small objects will not be affected so heavily as bigger ones. So if I would increase the scale of this guy, we should actually see a big difference. You can see the bigger the object gets, the richer the color, because the object gets thicker and the ray needs to travel further into the object. So more of the light gets absorbed. This is now a value of 20. At 10, this is like this. At 5, it's almost see-through. The last shader I want to create is a used gold-looking shader. So first, let's create the default shader again. As you might have guessed, there is no diffuse contribution, so let's disable this for gold. And head over to spec 1 and disable this for now too. And head over to specular 2 lobe. Increase the strength to 1. Change the mode from dielectric to metallic. Right click on reflectivity, choose gold. And change the distribution to GGX. Now you can adjust the values. These are actually measured values, so they should be quite accurate, but for the tutorial's sake, I will adjust them slightly. First, I want to create a really rough base gold look, something like this. And on top of that, I will add another gold with the same colors, but with a more shinier look. So first, let's disable spec 2, so we can only see what's happening on spec 1. And now slowly introduce specular 2 until you're happy with the result. You can see that there's a nice glowing GGX tail on brighter spots where you can see the effect of the gold. What I want to do now, using the same procedure as previously, I want to create a curvature map to break up the edges and also some broken up roughness maps. So first create the AL curvature and connect this to the specular 1 and 2 strength. First create an AL remap float, connect this to the specular 1 and another one to the spec 2 strength. Let's do it the other way around. First introduce spec 1 again until you're happy with the strength, something like this. And then bring back in spec 2 to something like this. These are my default values now. The curvature will generate a mask, so I can change the strength on the edges. So let's connect the R to the mask on both float maps. Change the mode to isolate selected and adjust the radius. Also, let's adjust the min values so we get an even stronger effect on just the edges. So these values drive the mask now, and whatever I change in here in the remap will adjust the specular one strength. So the edges now are not so reflective as the base. Let's see how this looks in the shader. Also, let's change the specular 2 strength. You can definitely see the effect happening on his belly. You can see that the edges are darker than the body. As well, let's introduce an overall blotchiness to this. I like to use an AI noise for this. And I want to combine the float values. I only want to change the base though. So let's create an AL combined float. Connect the input here and the other input here. And this drives, again, the specular 2 strength. Let's retranslate the scene. Isolate selected and select the noise pattern. Increase the scale to something like 50 and you get some nice looking noise. I think the value is now too big. So let's do something like 25. And introduce some more octaves. You can also add some distortion to get some more random looking patterns. Let's try even a smaller value. Let's say 15. Combined with this map, we get something like this now. Let's see how this looks in the shaded mode. Now we get some really nice, more accurate looking gold. It's a bit too dark maybe, but this is also because of my render settings. I actually don't have any indirect glossy rays, so let's introduce them. Now you can actually see what is happening with the indirect noise. It's getting way brighter now than I expected. So to compensate for that, let's change the specular amounts. First, let's disable both. And bring back in spec 1. And then slowly introduce the second lobe, which is the base. Now, if you also want to add some dust to this, just use the same approach using the occlusion and connecting this to your diffuse strength. Let's reuse my ambient occlusion and the diffuse strength node I have here. Let's connect the out value to my diffuse strength and change the diffuse color to something more like dust. Or just for tutorial's sake, let's create a really bright color for this. Maybe something blue. And this covers the power of the utility nodes. Of course, there's way more to it. I'm just showing you general and basic workflows using those nodes. But there's so many hidden options you can do, especially if you look at the AL input vector and scalar. But you can see you can use all those different shader parameters to drive certain values on in your shading networks. Another important one, if you have really complex shading networks, there's something called AL cache. And whatever you plug into this will be cached once and then it won't be recalculated again, which should increase the efficiency of your shading network. I hope I could show you something interesting, and maybe you can make use of this when you are shading your own models and doing look dev. Thank you guys for watching, and please give me a thumbs up and subscribe to my channel for more interesting tutorials about the new Arnold inside Maya 2017. Thank you guys for watching.